welcome back to Second Collisions and the main auditorium track, which is focusing on artificial intelligence, machine learning, and deep learning. The medical track is taking place in parallel in the Globe Auditorium. To moderate the first session, it gives me great pleasure to introduce you to my colleague, Markus Nordberg, who's the Head of Resources Development of the Development and Innovation Unit at CERN. Markus, the floor is yours.
Thank you, Rachel, and good afternoon, everybody. It's a real pleasure and a thrill to be here today. And I'd like to introduce Michael Feint. He's our next speaker. Michael has worked in particle physics at DAISY, CERN Fermilab, and KAK since a long time ago, in fact. And 1997, he has been, as of, a professor at KIT. But his work on neural networks started already earlier in 1993, as he was applying it to the data coming from the experiments at that time. And that led him to create and invent a neuro-based algorithm for predicting conditional probability densities. And that, in turn, led him to set up the company Blue Yonder, that he will share more exciting stories about just in a moment. So again, Michael, welcome, and I'd like to hand over the floor to you.
Yeah, thank you very much, and thank you for the invitation and for the introduction. Yeah, so my name is Michael Feint. As Markus already said, you more or less gave the talk already. I am a physicist by education, and I started my physics career at DAISY in Hamburg, then went to CERN. That was in 1983. Then I went to CERN, later became professor at KIT and made experiments there in Fermilab and KEK. On the right side of the screen of the slide here, you see the experiments I have worked with: Pluto, Cello, Delphi, CMS, CDF, CDF2, Bell, and Bell2. So I'm still doing it at the moment. I'm really focusing on the company, and you will understand this later. But since just a few years ago, I still had a large group, especially in the Bell experiment in the recent years, and we were very successful there. And I show you also something about that. So my machine learning history actually began in 1993 when I trained my first neural network at CERN. In 2000, later I invented the neural-based algorithm, which was a neural network for the output is a probability density, not only one value, one number, but a complete distribution. And this, I found out, was extremely interesting for applications also outside of physics. And that led me then in 2002 to actually try the first applications outside physics. And I founded my first company called PhyT. Then in 2008, I founded Blue Yonder, what we now call the original Blue Yonder. Later, 10 years later, Blue Yonder was acquired by the much larger software company JDA Software, and I will tell about, details about that later. 2 years later, JDA was then renamed to Blue Yonder because Blue Yonder, which was a smaller part of the large company, was actually the more up-to-date, more future-oriented and value-producing part of the company, so that the whole company renamed itself. And just now, in 2021, actually the complete Blue Yonder was acquired by Panasonic and at an valuation of $8.5 billion. So huge value. On the top of the slide, I show three things which were important for artificial intelligence. One in 1997 was that the chess world champion was a computer program, IBM Deep Blue, that we would today not really call artificial intelligence, but it was something where really something very difficult for humans was really being made better by a machine. So what we did, we also automated the work of particle physicists, so of ourselves, because we had lots of experience. And for example, for reconstructing exclusive BDKs in more than 1,000 channels, we wrote a program then which made it with about 72 neural networks inside, which made all the hard decisions. And we found then that on a 10 years data set of the Bell experiment, this program was 2 times more efficient at the same purity as the 400 physicists of the collaboration in 10 years, including myself, together before. And a few years later, in 2017, there was a second go of the same idea, but just even more efficient. And so this made the reconstruction efficiency 4 times as efficient as we were able to do as humans before. And when you know that just the operation of the Bell experiment for 10 years cost the costs were 0.7 billion, so 700 million euros about. Then to let's say, be able to efficiently double the luminosity or even quadruple the efficiency, corresponds billion euro in the first round and 2.1 billion in the second round. So it's a huge value. 2017 was also the year when AI became popular, so very popular, because the world championship in the game of Go was won by DeepMind, by a deep neural network in that year. So we started very early and were also very successful, quite parallels to DeepMind and so on, but also very different approaches that we had. So this was one of the things I did at the very beginning and when I was a CERN fellow in 1991, 1992. There the Delphi drift calorimeter was a very nice thing in principle, but the energy and spatial resolutions were catastrophic. And that was the first time I tried to solve this by software, simply by looking at data and into detail, because this had 144 modules, the calorimeter, and we found that every of the modules had different problems, but by looking really at data, we could solve lots of them. And that was a very large success. And really for me, I learned that with software, with looking at data, you can really understand lots of things much better than if you only think theoretically what could go wrong. Then, as I said, we started to use neural networks in 1993. They were not very successful and not very popular at that time. But then we found we could do lots of nice things. For example, bee flavor tagging. We had a neural network and it was much better in performance than the normal methods, rule-based methods. We did on the right hand, you see particle identification in Delphi with DDX measurements and liquid and gas ring emitting Cherenkov counters. Combining all this stuff, then we were again much better. Then the neural networks was something very decisive for my whole life. First, it was an algorithm based on a neural network architecture, which could, for real valued quantities, not only give a mean value or predicted value, what comes out as a function of lots of input variables, but the whole distribution. You see it here on the right lower plot, also on the right in the upper left plot of the lower quadrant. That is a CDF and the PDF of the output distribution, individual distribution, could be learned by this neural network. Later, I found that this has huge value for economy. So we gained lots of experience with neural networks in Delphi. And over 10 years, we were extremely successful in inclusive B reconstruction, energy, directions, Q values, flavor, tagging, and so on. B plus 0, BS lambda, B separation, and so on and so on. I don't want to go into details. And we also were in the press in the first time at that time when for the with the that was later the year with the CDF experiment or CDF2, we discovered B, or really made clear that BS mesons oscillate, and we could measure the frequency of that. And that was also due to lots of other neural networks that were helping there. Okay, I talked about this already. This was the Bell experiment, in the thing that more than I think it's the second edition, more than 3,000 different decay channels, an automatic reconstruction of one of the beam mesons. There's always two beam mesons to the same event, and then you can, you know exactly what belongs to the one, and then you can do enormous good studies of the other beam meson, and you know the flavor of that at production time. Very important for time dependency, p violation studies, and so on. And then we also did things really together with other institute at KIT, so that we put this neural network into an FPGA chip, so that good decisions could be done on trigger level or even on readout level of the experiment. And we had a world record there at that time of 8 billion intelligent decisions per second with one chip. So that's the physics part, but then I had the idea to do something completely different, but with the knowledge that we gained at CERN, and as I go outside of the ivory tower of physics and think now that we have a measure where we can do nice predictions with a neural network, including all the uncertainties. That was very new. So we had also predictions of individual uncertainties. What I had done privately was a bad thing. I lost money at the equity market here at that time, but we had just moved to Germany back and wanted to build a house. And in this time here, where it was rising, we planned it a little bit larger than everything. We lost about 20%. That was not good. And that was a time where I thought to myself, the whole day you are doing nothing but statistical analysis and complex predictions, but only for physics. But if it were for my own money, I trusted a bank advisor. And I said, never again. So I downloaded Yahoo Financial Data at that time, used Neurobase for predicting equity price changes, and saw that on short-term scales and small amounts can be predicted. So on paper, we saw some predictability, and we had first contacts with also a car insurance. So again, something very different. Basically, we had access to accident databases, and we could really also predict quite a lot there. And that then was the idea. Okay, we will found a company, and this so with just two students. So that had the luck that they were just there at the right time, at the right place, but they were also good, of course. I founded then the first company, Physics Information Technologies, FIT. And so we did then also some predictions. For example, this was for Germany's largest drugstore chain, DM. And what you see here is the prediction of turnover of every of their more than 1,000 stores at every given day. And you see really here error bars 1 and 2 sigma intervals. And in red, you see then what was the truth, but we didn't know the truth before. Of course, this was predicted from historical data. And so this worked extremely well. And we did do lots of things and won lots of competitions in different areas. Then some financial companies became interested in that, and we actually built a low-risk, market-neutral fund for institutional investors, the Lupus Alpha Neurobase short-term trading fund, which ran over 6 years and made very good money. Also there we were in the press quite often. And then we made a test for Otto, Germany's largest distance retailer, and competitor to Amazon in Europe and especially in Germany. And we saw that we could make much better predictions as they did for how many of every single item they sell in the next short term or also the next half year and so on. Then someday my telephone rang, and it was actually the boss of the CEO of Otto, and he wanted to buy my company. I said, okay, no, I don't want that, but we can found a 50-50 joint venture that was then called FIT Products and Services. That then we started in this company professionalization. So up to then we were only physicists, so data scientists, mostly physicists or mathematicians, IT guys. But then we also introduced sales, marketing, PR, finance, engineering, IT infrastructure, product development, HR, a growth plan, and so on, and built a real company. 2011, then we renamed this company from the clumsy name for IT products and services to Blue Yonder. Blue Yonder stands for behind the blue horizon. It is this what normal people on Earth cannot see, but a pilot on a plane can see. So, and this should somehow tell us that this company can see look further into the future than others. Now we decided, so we had lots of projects at that time, also for industry, for insurance, for different things, for retail. But then we then we had a big investment of private equity in 2014, and we decided to really concentrate on products, build products that can be used for many clients. For example, demand forecast with probability distributions for retailers, replenishment, also using an individual cost pricing for retailers, causal program with individual customer targeting for retailers. And so we concentrated on large customers and repeatable things and internationalization. We changed from Fortran and C++ to Python then. We changed our own data center that we had to the public cloud. Now we are one of the best partners of Microsoft Azure and do everything there. And from what was at that time called an unpopular renting model, so that the software was not as bought but only rented, we changed nothing but the name, because this is what we had before already was software as a service, so that we also ran it and operated everything. And today this is cool. Then in 2018, Blue Yonder was acquired by JDA. So we had, for some years, we had lots of companies that wanted to buy us. But this was the first time where we thought it makes sense. JDA was a competitor of ours from America, 40 times as large as we were, but they were more classical software, but for the complete supply chain, and they they were really good and very well underway in the whole world. But they did not have really machine learning, data drivenness, and software as a service. They were just going into that direction. So this made much sense to come together there. JDA was very clever, so started in '85, and then acquired the world best demand management companies and the world best planning and transportation management companies and the world best warehouse and labor management companies, and then Blue Yonder. And so this led to one integrated set of end-to-end solutions for the whole chain. And the vision of JDA at the time was, as a moonshot vision, the autonomous supply chain. So first have visibility over the complete supply chain and everything from manufacturing to via transportation and so on up to the retailer. Then a predictive application inside, and prescriptive and autonomous, finally autonomous. And that is what we were building together with them and what we have now. So you see, from suppliers, fabrication, transportation, distribution centers, distribution to stores and online stores to final customers. And we have lots of stuff there, demand prediction, store orders, supplier orders, truckload building, and so on. And everything is automated. And we have built one AI-powered supply chain platform for doing all this. Now came the day that I'm very proud of. In 2020, what we started as JDA there ended as Blue Yonder. So the whole company rebranded itself into Blue Yonder, because what small 2.5% of the company was putting in was the future. Now the new Blue Yonder has about 3,300 global customers, 5,500 professionals working for it, and annual revenue larger than $1 billion, 450 plus patents granted and pending, 75 of the top 100 retailers of the world use Blue Yonder. 7% of the top 100 consumer packaged good companies of the world use Blue Yonder. We have about 25% EBITDA, strong cash reserves, about 150 customers per year, and we are the only company in the world that is named a leader in all four Gartner Magic Quadrants. Gartner is a software evaluation company that always compares the software companies in different areas, and in every single supply chain, Blue Yonder is in the top quadrants. Yeah. We made, and this is also, I'm proud of this, we now do about more than 10 billion automated AI decisions per month for our clients, and it's growing fast. So real AI also has to scale. That is not only the algorithm, it's a complete development behind it for scaling. That's very important. And we have delivered more than 1 trillion predictions already to our customers in total. I'm also proud that we serve profitability, not only profitability, but also sustainability. So you can steer the strategy of what the companies want. Is it only profit, or is it a mixture of, for example, also sustainability and avoiding food waste? And that is absolutely possible. So I'm almost at the end now. Just this year, I said it already at the beginning, we were acquired by Panasonic. So the first you think, why Panasonic? They are a hardware company. Yes, they evaluated Blue Yonder to $8.5 billion. We're also very proud of that. Brand and company will stay and grow, but we put together, Panasonic builds lots of sensors and edge devices, IoT devices, and for putting in data from the edge into the software of Blue Yonder and building appliances. That is what our future wants. So I'm almost done. This year is just some things: understandable, interpretable AI, economic AI, sustainability in AI. These are stuff we have already productized. We are working on fair, discrimination-free AI, on causality, reinforcement learning, and long-term, it may be that we will have applications for quantum computing. That is not yet clear. So, but this is also really very exciting things. And what I have learned, this is also an important message. Not only particle physics is interesting and demanding, also in the rest of the world, they're extremely fascinating tasks, and you can have really influence. We really have influence now in the world, because lots of the largest retailers of the world use our artificial intelligence. The first ideas of that were really coming from when I was working for CERN. Thank you very much for your attention.
Thank you very much, Michael, for sharing this fantastic journey. And I understand from my colleagues that the participants have the possibility of asking questions through the chat link. So I'm looking at the shared document from Lisette. I don't see any questions there so far. But while waiting to see, Michael, if there are questions, let me ask a little bit elaborating on the early part of your work. So could you share with us this transformation from a hardcore statistics, high energy physics guy into something that is kind of, let's say, call it more useful for society, at least seen by our family?
Yes. Yes, so that was quite some transition. So the first thing I had to learn was that I have to give talks without any formulas. And also with graphics must be very simple, words must be simple. So one has to communicate on a very different scale, but of course without losing the trust. And I think it was, for us, it was very important that we have really these two things. So we have this hardcore scientist in the company, but of course we also must have, so you're not allowed to be too modest. You must do PR. You must communicate. You have to go out. You have to work with the press. You have to go to conferences again and again. Many of these things are also important for a career in academia. Right? Also there, if it's only you who knows that you're doing great things, it doesn't it's not enough. You have to go out. You have to tell it to people. You have to make it public. You have to build trust. So I think this is important. But then you also have to learn that money is not a bad thing. Right? Because only if you have money, you can do things. You can create jobs. I was, for example, extremely proud when I always saw on the Christmas parties that we had 200 people, most of them actually good scientists, were sitting there, and some. Then I thought, okay, of course we did great work. We worked as in CERN, so in teams, not alone. But of course, as I also knew, okay, it was my idea that now gives good money and permanent position to all these very clever guys. This is something. This is really a great feeling. So yeah, I think it's a bad thing that often academia and economics are so separated. Right? I think they should be much closer together and work closer together. And very often, I think it is. Yeah, so scientists are also sometimes only interested in their bubble and nothing else. Right, and in academia, in economy, it's often that the powerful people are most of the time not good scientists, but good speakers and good managers. Also, brings things together in order to have an influence on the world.
Okay, so we have a question. Michael, did you patent Neurobase? Did you patent anything else?
Actually, at the beginning, not, because then we also thought it was not yet possible at that time. So what we did there is that we, let's say, kept it secret. But it was we always had a running version for CERN and for physics that was for free, but not with the source code. And, that was not public. We did not. Yeah, at the beginning we did not patent it, but so since when we were larger, we actually started to patent algorithms. For example, the main algorithm that we are using now is called cyclic boosting, that we patented, but we also then published it. But we also don't give the source free, because of course in the economy it's lots of things are also stolen directly. So we have quite some companies that try to copy one-to-one what we were doing. I had this in physics also already, but in economy, of course, it's even more dangerous. So yes, the new algorithms, we have some new algorithms patented, but the original ones were actually not patented.
Okay, so we have a couple of more minutes here. So I'd like to, we had a chat beforehand, so I'm privileged to know a little bit more than what you said. I understood from our chat that, Michael, you are your baby has grown up, it's very successful, you're clearly a proud father, you should be, we all are. I understood that you are kind of looking back to your professorship at Karlsruhe. So could you maybe share what your next baby might look like?
Yeah, I don't know it exactly, I must say. So, of course, I still have an important role to play in Blue Yonder, and now with the Panasonic. It's also interesting and new things again, where I think where one of the options is clearly to stay there. But that there are other things which are very interesting. So of course, I also know some small young companies. So it might be that I also already do some coaching and so on for new small companies, also smaller investments that I do there. That is of course something which is also interesting. But for sure, at least I want to give also lectures, maybe not beginning physics lecture, but how to really scale AI things to students, and also about entrepreneurship. So this idea, so what are the errors that you should avoid and so on. That I think is also very interesting, and I like to share this, my experience there. And of course, a university is always a good thing.
Well, thank you very much, Michael. It was really a pleasure to see you here today, and Thank you for sharing these exciting developments, and I hope that we will be able to follow your new whatever you are going to be working on. And I think we have about 2 minutes left, so if you still want to share something, please go ahead.
Okay. Yeah, I think that two things. So first, what is really interesting is that for physicists, for clever, analytically thinking people, there are lots of interesting things around, and so one should, take the chances and do that. We are also growing and are also looking for people for especially I'm always looking for physicists since I know that they are so great and have the right mindset in order to really build something new and exciting. So that's that's an important message. Then I think also for the physics community, we see and also with the whole development in AI, we see how important knowledge is there. And so I'm also in my public speeches and when I talk to the press, I'm always saying we need more people in this area. We need more people studying mathematics, information sciences, natural sciences, these things. It should be more popular. And I think when I see how it is in Europe, also in North America, then I see how much effort in India, and they are much, there's more willingness to do the hard studies, the hard topics, and this is something that I would like to also make advertisements in Germany and in Europe and in North America too, because I think there are so many things to be done, and it's so interesting, fascinating, and we need more intelligence and more work there.
Okay, thank you. So your mobile phone might be ringing a lot, Michael. So thanks once again. I'd like to thank you all for joining.
One last word. On LinkedIn, simply with my name, Michael Feind. So please follow me there. From time to time also I post something very technical, which might be interesting.
Yes, we saw that actually your LinkedIn page there. So please, everybody, go and chat with Michael. And thank you again for joining. And back to Rachel and other colleagues in the studio. Thank you.
Bye. Thanks.
Staying within the AI, machine learning, and deep learning theme, it gives me great pleasure to introduce our next moderator, Enrica Maria Porcari. Enrica is the newly appointed head of the IT department at CERN. Previously, Enrica was the UN World Food Programme's Chief Information Officer and Director of Technology and Chair of the UN's Emergency Telecommunications Cluster. Enrica, the floor is yours.
Thank you. Thank you, Ash. It's a pleasure to be here and to be part of the second collision event here at CERN. And it's a great pleasure for me to introduce to you Sharada Mohanty. Mohanty is the CEO and founder of AI Crowd, a platform that organizes artificial intelligence and machine learning challenges to solve open science problems using open data. And Mohanty is obviously an alumnus of CERN with an impressive background, but I'm sure most of you will have read it on the website. So let me get to the core of this fascinating event today, and which will be comprised of 20 minutes where Mohanty will share his thoughts, followed by 10 minutes questions and answers. And I invite here all of you in the audience to start posting questions on the chat live. And then we'll proceed with those questions. Mohanty, let me give you the floor.
All right, hello everyone, and it's great to be here. I'm waiting for the slides. All right, hello everyone, and it's great to be here back at CERN speaking about something that I care about deeply, artificial intelligence. And this talk is titled Crowdsourcing Artificial Intelligence to Solve Real-World Problems. And we will be talking about 2021, where AI is hot. Everyone wants to do AI. Only a few people know how to do AI, and fewer know who those few people are. And if you think about it, there was this report from 2017 where we realized, Tencent reports that there's about 300,000 AI engineers worldwide when millions are needed. And that gap is only increasing with time. And the perception is AI is done by a handful of people who do a lot of ugly maths in front of a whiteboard. And that is not solving the whole problem, because we want to convince a lot more people that you want to kind of jump in and help us build these tools that's going to impact all these billions of people. Moving on, we will take a small detour and talk about Bob. Bob is a simulated skeleton who lives in a simulated world. And as a part of our research, we asked this question. Bob had 18 muscles, and you have to send signals to all the muscles of Bob. When you send a signal of 0, the muscle is completely relaxed. When you send a signal of 1, it's completely contracted. And the task is, can you coordinate all these muscles in a way like a master puppeteer so that Bob figures out how to walk or run? Now, when we started working on this, we realized it's a hard problem. Bob takes a single step, falls face down. But with time, we realized, okay, you can actually make it work. It takes one step, a second step, but then it falls down. Then Bob got a bit smarter, and Bob figured out how to cheat. We told Bob, your job is to kind of move as far as you can. And when it realized that it cannot get the third step right, it just started figuring out how to kind of do a perfect dive. Now that was great, but we kind of figured out how to kind of get around that. And finally, we had Bob actually walking, trying to walk like us humans, but not very human-like. And that was because we didn't account for how muscles are energy expended in muscles and whatnot. And a bit later, we had Bob walking like us humans. The first time we actually saw this, we were like, wow, the whole thing can actually happen where Bob just learns how to walk by trial and error. And by the end of it, we had many little Bobs kind of going about their day, just running all around. And some of these models, they were running at about 5 meters per second. And that qualifies you for the Boston Marathon. The interesting bit is, this whole project, it basically started as this nice, difficult problem that a PhD student would work in. And I was at APFL, and my collaborator was at Stanford. We started working on it. But we approached this problem a little bit differently. Instead of working on this problem where we work on this problem for 6 months, a year, publish a paper, then go talk about it, as soon as we started working on the problem, the key idea, and before we had the results, we put it out there and invited people all over the world to come in and help us. We were like, hey guys, we have this cool problem. You want to come and help us make it work? And we had hundreds of people who came together to help make this happen. And that itself, just seeing these hundreds of people collaborate, was amazing. Now, what happens in the process is, we clearly define the problem, and these people, they submit their trained models, and we have an automated setup in which all these models are evaluated, and then we get to see how good a particular model is. And in the process, we can objectively evaluate thousands of submissions and put them up on a leaderboard. In the process, we discovered these hundreds of people that we would have never met. In a traditional setup, when I'm working on this problem, I would be working with a few other collaborating labs. We would go to the same conferences. We would meet other PhD students, postdocs, other researchers from industry, all of us kind of very excited about this problem. But here what happened was something very different happened. We had people who were not our traditional academic crowd. These were random students from India, China, Africa, all over the world, who were contributing these because they thought it's cool to kind of teach a simulated skeleton how to walk, and they did not know how to, and they were learning. In the process, we got these feedbacks where we realized, oh wow, it's not just these advanced researchers who are working on this, but people are kind of trying to use these problems to learn, and along the way, they're helping us solve these difficult problems, in many cases bringing insights and perspectives that we usually may not think about. Now, overall, we quite love this community. And over time, we try to replicate it as much as we can. But how? How did this whole thing happen? So the story of Bob was interesting, where we got lucky and NVIDIA came in and they said, this problem is gaining a lot of traction. It's a difficult problem. Anyone who solves this problem has the best solution. We give you NVIDIA DGX1, which is like a little supercomputer in a box. As someone like me, that's a very attractive incentive altogether. But that's not always the case. In many cases, we also bring in these people as co-authors in these papers, right? And there's also cash prizes and whatnot. In the process, to make it work, like what does it take to get all these people to kind of work together? Where we do not start with any assumptions. We put in a lot of effort into ensuring anyone can jump into these problems and start working, irrespective of their technical background, irrespective of how used to they are to this research problem. So we make these resources available so that anyone can come and help. And that takes a lot of effort. But you start seeing the compounding value of it as soon as you start these hundreds of people come in and help out with these problems. Now, one important thing that we try to kind of send across as a message is that you do not need to know a lot of ugly maths to be able to do AI. And that needs a lot of these resources that we create, but also a lot of abstractions that we create, like code, documentation, and whatnot. And another bit is what we say is what we as AI researchers do in many cases is we play a game of Lego. Many of us, we create these little Lego blocks and we really spend our careers understanding what these Lego blocks do. But that does not mean that everyone needs to understand how each Lego block is created. You need to develop these intuitions of how these Lego blocks work, how to put together these Lego blocks so you can build your beautiful, magnificent castles. And these castles are these tools using AI, which are going to affect millions and billions of people. And we want your help in making that happen. Now, people moved away just from these problems of teaching Bob how to walk. Then we started kind of having a lot more problems. Then we had problems where people would come together to play a game of Doom. Very much like you were teaching a simulated skeleton how to walk, now you were kind of controlling these agents inside Doom. And we have this very popular thing in Minecraft, where people submit these hundreds of models which do large, complicated tasks inside Minecraft. Then apart from Minecraft, we also have things where the users and the participants, they look at lots of satellite imagery. They train models which can look at lots of satellite imagery and detect buildings in it. This was with some humanitarian organizations in place. And this particular example is interesting because traditionally, many of these tools which are at the forefront of technology, they may or may not be accessible to other traditional organizations, right? They're always accessible to technical organizations like Google, Facebook, and whatnot. But other organizations, like many humanitarian organizations which are impacting billions of people, they get to access these tools with a latency of a few years to decades. Now, these organizations can come up with their problems, and suddenly hundreds and thousands of people are coming together to help solve these problems, and they're realizing, wow, there's a cool way in which you can use satellite imagery to just analyze how refugee camps are kind of evolving over time. Then we had other problems on how do you kind of fool these neural networks, where we had one group of people trying to train robust neural networks which cannot be fooled, and another group of neural networks which are trying to fool these neural networks. Imagine you're given a picture and you have to add a little bit of noise so that we as humans cannot see it, but an AI gets completely confused. That can be really disastrous in context of, say, self-driving cars, where someone puts a sticker on a stop sign and now the AI thinks it's not a stop sign, but it's a big green light. Then we had problems with Spotify. Can you predict what the next, if a person will skip a song or not? We had something with Firmenich here, where we asked the question is, what does it mean to smell? Can we have AI models look at the molecular compounds and predict what is the smell of a compound? And that itself is actually a very hard task even for humans. In many cases, people train for decades. But we had great solutions in the process. We had another project which we have been kind of working on for quite some time here is how can we use AI to analyze food? What does it take for the AI to kind of look at food images which are submitted by hundreds and thousands of users from all over Switzerland, and the AI has to look at these images and simply segment out what food is in there. And the goal there is to be automatically and better analyze what is the nutritional consumption of populations at scale. So someday we can answer what is Switzerland eating today. And here also it is very interesting because the whole project started as a research project at EPFL. Then we opened up the door on the AI side of things, and then hundreds and thousands of people are submitting these models. And in the process, we actually collected 2.5 terabytes of user-submitted code and model. And these models are currently being used in production, where many users from Switzerland who send these images of food that they eat every single day are analyzed by these models. Then we have some stuff with Microsoft on how do you use drone imagery of sorts to kind of do these understanding how these spaces are structured. Then you have something which is very close to my heart here in Switzerland. It is with SBB, Deutsche Bahn, and SNCF on what does it take to schedule trains in a railway network. Because scheduling trains is easy, rescheduling them is different whenever there's a little deviation in the network. And how can you basically have these AI models which are dynamically controlling the speed of the trains, the direction of the trains, telling some trains to halt and whatnot, where again you're like a puppeteer which is kind of coordinating this whole network so that you have minimal delays across large network. And this is interesting again also because it started as a small side project at EPFL, but through AI Crowd we not only managed to kind of gather hundreds and thousands of people all over who submitted their solutions, but we also managed to bring three major railway companies in Europe to come together and work on this problem out in the open, like an open research project. Moving on, then we have some other stuff around simulated markets and how can you have a setup where people are submitting these AI models which are trying to get into a bidding war in the process of figuring out what the insurance premium should be and whatnot. In the process, you are actually ending up creating a simulated a virtual market of sorts that can be used by organizations to test out their hypothesis. Because traditionally, the same organizations, whenever they have a hypothesis about pricing, they will basically try it out in the market. It will take months to a year, and then they will get feedback, so iteration cycles are slow. Having access to a proxy simulated markets gives them ways in which they can try more optimal strategies for figuring out better prices for all their customers. Moving on, all the problems do not have to be intense, hard research problems, because this is also a community which is very welcoming for people who are here just to learn. So every month we run something called as AI Blitz, where we design 5 puzzles, and in 3 weeks, we encourage people to kind of jump in and try to solve all of them, any of them or all of them. And in the process, people who are trying to learn, they have these small, easy to bite problems to kind of get started on their journey in AI. And we create a lot of resources. And there's also a very helping community of users who are very excited about helping others and also solving these puzzles along the way. But the one hypothesis with which we start all this is that tools powered by AI will have a significant impact on each of our lives. Well, actually, it's already having a significant impact on each of our lives. And going back to the report that we talked about, where we only have 300,000 AI engineers worldwide when millions are needed, and the perception of people that, okay, to do AI, you really need to know a lot of advanced maths and whatnot. You have to probably spend decades before you can actually do anything meaningful in AI. That is something we have to kind of change, and it's important. A good parallel for that would be, imagine web development in early 90s. In fact, here we are speaking at CERN, you can make a case that at one point, all the web developers in the world were just around here at CERN, not very far from here. And now look at us, look where we are now, where we have millions and millions of web developers all around the world creating tools and services which are impacting billions of people. And the same cycle will be repeated. The same cycle will be repeated, but for that to happen, we need each one of you. We need each one of you, and we want to convince each one of you that each one of you can make meaningful contributions in AI. Each one of you can build impactful tools in AI, and there's a community of 50,000 AI researchers and enthusiasts from all over the world who want to kind of work with you along that journey. And if you do not know how to kind of do that, because that is usually the first thing, I do not know where to get started, what to do, then here there are hundreds of excuses to learn how to, with thousands of people who are also learning with you. And while along the process, they're solving meaningful problems that matter as a side effect. And what's there to lose? If you spend a weekend trying to kind of work on these problems, along the process learn something in AI where you're analyzing satellite images, then you have a good story to tell. Whenever you grab beers with your friends the next time, you can say, oh, you know what I did last weekend? I solved this problem of analyzing satellite imagery using AI. And then you could ask very much, what is it in it for me? Why am I actually spending so much energy, time, attention in trying to make it happen? So here, the hypothesis is that right now, much of research happens in a handful of places. Only individuals with privilege are able to contribute to progress in AI, and I don't have any complaints against that. In full disclaimer, I was at EPFL. In fact, the reason I probably am doing research in AI and I've been speaking here is because of the privilege I was exposed to at EPFL. But my question is, does it have to be this way? Does it have to be the only way? And is it the most optimal way? I want to imagine a setup where we can have millions of people all over the world who self-organize in these communities to push the frontiers of research in artificial intelligence. Right now, the research happens in clusters of labs at privileged places, EPFL, MIT, Stanford, industrial labs at Google, Facebook, and whatnot. But I am imagining a parallel, giant distributed research lab which is for the people and by the people. And the story is what Wikipedia pulled off in terms of organizing millions of people all over the world to organize all the information of the world. I'm pretty sure we can replicate the same story of organizing millions of people all over the world to come in and push the frontiers of research in artificial intelligence and to build tools which impact the lives of millions and billions of people using artificial intelligence. And thank you so much, and I would open up the floor for any questions anyone has.
Wow, Mohanty, what can I tell you? It's just, listening to you, I got excited about coding and AI. So I think the power of community, the opportunities that it's, being all in this, the democratization process of bringing science closer to the people, it's fascinating. So I'm happy to share the podium with you, a safe distance from each other, but let me ask a question that really came to me as I was listening to you. Your enthusiasm is contagious. Now, what is it that being at CERN contributed to this, to your energy, to your enthusiasm, to your insights?
I think I have always been a little bit hyperactive, but at CERN, I'm pretty sure there's something in the beers at R1 or something. Because how often does it happen that you are actually walking around somewhere and you're having lunch, and next to you, as in there's a Nobel laureate casually having lunch, or it just happens that your supervisor also happens to be in the Internet Hall of Fame. But when you are surrounded by so many people who are dripping with inspiration, then some of that brushes on you. You're like, wow, you can do a lot of things. Look at, if these people can do it, maybe I can too. So that gives you that confidence to actually kind of jump in and really try and tackle hard problems which you might not have. And also this community of people at CERN, it's also kind of something which also kind of creates that environment where you're also encouraged to do the same, where not only people are kind of having this inspiring others, but they're also getting inspired. So you walk into this place and you're always being inspired, and you know you have a responsibility to also inspire others. Right.
Yeah. I mean, it's actually quite true. The circumstances are quite complicated right now. During the COVID situation. But I could see as people come back to the campus, that energy flows and hits you the moment you come in. And as I said, it's a shared gain, right? You contribute to this energy and you take from it. It's really powerful. Thank you for that. But now, your talk must have inspired many people out there to say, I want to be part of this. Mm-hmm. Now, how?
So there's many ways, right? You can come in. Some people just come in to kind of come into the community, just watch what are the problems being solved, how are they solved, and whatnot. But some people come in to kind of learn. So you can come sign up on AI Crowd, pick up a problem that you fancy, and then start working on it. We spend a lot of time on creating resources so you can get started on them. Or if you think you have some problems and you just do not know, you somehow know that it can potentially be solved using AI, then you do not know how to kind of even get started on that, then this is also a community where you come in saying, hey guys, I want to work on this problem, I have this idea in mind, I have these data sets, and is anyone interested in coming to help solve these problems?
So what I do, send an email to you? Tell me how to do it.
You can definitely send out an email to me, and you can also post it out in the forums, because I started the whole thing by just putting out there saying, hey, anyone is interested to help with this. But you can, if you have any problems, you can definitely reach out to me. I'm always on the lookout for interesting problems, because there's a community of 50,000 people, and it's my job to ensure they're always entertained with good problems at all times.
Wow. So you brought us back a few years ago when at CERN, the sparks generated the ideas of the World Wide Web, and you said it was enclosed. Now it's open to the world. And I think it's this power of a more democratic, open platforms, the multiplier effect. One of the questions from the audience is knowing this trajectory, how do you imagine the world in 10 years' time?
That's a pretty loaded question.
Yes.
So basically, 10 years ago, 10 or 15 years ago, we never even imagined what just the existence of web would do. Mm-hmm. Just when so many people can efficiently talk to each other, and the fabric of society was, there was a catalyst in the fabric of society. The cascading effects were pretty much impossible to imagine. No one thought that just because of having an efficient social network out there, the democracy of a whole country like the United States would be undermined. Now, in context of AI, the same unpredictability in the trajectories will probably come in at a much more highlighted setup, where we can talk about many applications of AI and how they are facilitating many of these interactions. But it's really hard to kind of put a finger right now on what exactly that future would be. And only because I do not want to take that responsibility of imagining the future. My goal is, how do we enable these millions of people so everyone can imagine these features and better prepare for them? Yeah. Because some of them are dystopian, some of them are utopian. Exactly. So people need to be able to kind of imagine these features. My version of future is probably somewhere here. The actual one might be very different. But if everyone is everyone is enabled to kind of imagine these features, then at least someone will have kind of imagined a small version of the future, utopian or dystopian, before it actually arrives.
Well, but I think it's also not only imagining, we can actually be active contributors to this, right?
So
there is a big white canvas out there, we can all paint on it. So I think it's maybe some of these tools would allow us to contribute actively to a future the way we want to see it.
Exactly, yeah. So that's the point with this, right? So if a handful of researchers, irrespective of how smart and how good they are, build this future using AI, then there's a higher chance that they can go wrong. But if there's millions of people building this future, we are much better prepared for that future.
Exactly, this unlocking these potentials. But there is a question from one of our the friends in the audience that says, do you see any risks in this opening up and in the use of the tools in the hands of so many?
Risks. There are risks. So like with any kind of technology, there are risks. And right now, there's many ways in which AI can be abused, right? For example, autonomous weapons and whatnot. But the research community right now is coming together, and the AI research community in general, I'm actually proud about that, about how they're kind of more focused on building these shared values in that sense that, okay, these are the risks we do not want to explore, enable, or facilitate. And these are some things we really want to kind of positively contribute to. But there also is the same question. Is it only a handful of people who are just trying to think and address these risks, or many people at the same time, millions of people are enabled to kind of imagine and address these risks?
Democracy in action, isn't
it?
Yeah. Now, democracy requires a community building, a very active, engaged community. How do you keep this enthusiasm going? How do you keep this energy and the positive of...
That's also, again, I think about that a lot, right? Because we have these discussions, okay, we probably need a whole army of community managers to kind of do this and whatnot. And they also would come in and they would like, okay, we have these plans in mind, we do these events and whatnot. But I think from basic fundamental principle point of view is to kind of gather a small group of people who really care about it, right? Who are very passionate about it. And they are doing it not with not the optimal goal, not the eventual goal of gathering these thousands of people. They are just doing it because they love to do it, and they will do it even if no one is watching. And in the process, when these people are extremely passionate and they just keep doing it with infinite patience and infinite persistence, then other people will follow along. The community will come in place. After a point, then there's a question of how do you maintain the hygiene in the community. That needs a little bit of planning, like you kind of have your shared code of conduct and whatnot, or like some regular events so that the community can come together and whatnot. But the initial momentum needs to come from a small group of people who are extremely passionate about it, and they would do that even if the community is not there. They are just inherently that motivated to do that.
That's great. There's also a lot of community control, right? You know, people watch out for each other and watch over each other. Now, there was a question about green economy. I mean, AI, machine learning, you know, computers in general becoming more and more pervasive. And how do you balance its impact on the environment with the benefit?
Yeah, so at this point of time, AI does consume a lot of electricity. So when we are running these whole farms of GPUs to train these large language models, it does burn a lot of energy. And then basically, the whole argument of is it like a good decision to utilize all that energy in this exploration around AI and whatnot is a separate one, right? Because there's the whole long-term benefit, short-term benefits and all that stuff. In the short term, I think the AI community or the research community in general, they are trying to be carbon neutral in a sense, where when we run many of these challenges, and some of these challenges, we end up burning about $50,000-$60,000 of compute. But then for that compute, we always try to ensure as an organization, are we carbon neutral? Are we actually doing some carbon compensation by also having this as a habit, as a part of our culture, that we are contributing contributing our share for the carbon compensation around it. So there it's more like a question of establishing that culture around it. But there's no denial that yes, a lot of energy and electricity is being kind of used in the while we explore AI. But the question that we probably are betting a lot more is that the benefits in the long run will outweigh when we unlock some of these tools, which will help justify the investment that is going in there.
Absolutely. Well, we'll look forward to that. Mohanty, we just have a few seconds left. There were a lot of questions I couldn't answer, but you have 10 seconds to leave the group with a thought, something you want to share with the audience out there.
I have 10 seconds.
You have 10 seconds.
I think for me is, my pitch has always been to try and see, can we actually build this another Wikipedia by organizing these group of people where the people are not just organizing information, but they're also looking for other information. I think
I'm sure we can. Thank you. Thank you, Mohanty. So it was such a pleasure having you. Good luck.
Well, we come to our final talk in this topic, and to moderate the next talk, I'm delighted to introduce Katja Mankindenan. Katja completed her PhD in 2020 at Lund University in Sweden, working on the Atlas experiment. She's now a data scientist at the CSC IT Centre for Science in Finland, where she's focusing on helping national organizations make the most of the potential of big data and advanced analytics. Hello, Katja.
Hello. It is my pleasure to introduce the next speaker, who is Charlotte Valderrin, who works as a data scientist at Procter Gamble. Charlotte completed her master's in particle physics in Geneva, and during that time, she worked for the Atlas collaboration and gained a passion for data science. She then worked as an international consultant in big data and did a postgraduate in applied artificial intelligence at the University of Brussels. So we will now have 20 minutes presentation and then 10 minutes for Q&A. So please post your questions to the chat. And now, please, Charlotte, the floor is yours.
Hi, everyone. I'm very happy to be with you today. Thank you, Katja, for the introduction. Very difficult to go after such an interesting talk, but I'll do my best to keep you interested. So my talk today will be a brief history of a high-energy physicist from aeronautics to consumer goods. After that, I realized two things. There is a G missing in high-energy physics, but that's okay. And it was quite kind of arrogant to take back Stephen Hawking bestseller on the origin, structure, development, and eventual fate of our universe to talk about my professional small experience, but it was actually meant as a tribute because it's the book that I read, and afterwards I went on to study physics. So what are we going to talk about today? Why are you here? So I really wanted to go back to the original to the original purpose of this event. How do skills developed at CERN can contribute in the society? And I'm going to bring you through my journey with my little backpack of knowledge that I acquired at CERN and how I went through to use it in my journey. I will try to go very quickly because I really want to leave time for any questions because I think it's the most interesting part of the talk. So it started in 2016 when I started my master in particle physics at the University of Geneva. During that time, I had the opportunity to work in the Atlas collaboration from the university in the CERN facilities with people that you might know in the Atlas collaboration. Professor Giuseppe Jacobucci, Dr. Steven Schramm, Dr. Roland Jensky, and we were together trying to answer the question, how could we improve diboson tagging efficiency? And here we were combining data coming from, I was learning on my side a lot, from the tracker, the calorimeter, to apply certain cuts on just substructure variables in order to distinguish between QCD and actual signal. And there, I learned the basis of what I would need in my future jobs, not only Python and C++ skills, but also and mainly attention to analysis end-to-end, from data ingestion to quality assurance, explorative analysis, modeling, up until to sharing results. Also the curiosity of understanding and coming up with new solutions to figure out the problem and how a big data collection system worked, and how we could use it to provide insight. So here I was with a little backpack of these skills and ready, super motivated to go to the next chapter. But I didn't know what was it. So I had two PhD opportunities that was the obvious choice, but at the time I was 22, and I was super interested in the buzzword, machine learning, data science, and I really wanted to apply it in the industry because I had no idea what it would look like. So it's how I ended up at Akka Technologies, which is a consultant company in engineering, providing solution and consultants to companies like Airbus. And that's where I worked for a year and a half at Airbus. And here I was asked different problems. One of the questions was, how can we track business impact of defects on airplane pieces? And actually with my backpack of skills acquired at CERN, it was quite an easy question in the end. I mean, it became easier thanks to these skills because they had basically a big data platform where you had the end-to-end process in place. You could ingest data, transform them, apply analysis up until the reporting of it. You had a PySpark environment integrated in it. You could basically run as you were running on your computer, but with much more computing power. So I had my machine learning use case. I was very happy with it. And I could, up until the reporting of it to the business partners. That's where I had my first business presentation, actually. And then as we move on, we have other type of problem. How can we plan tests on airplanes and make sure that we have all the necessary components to do so? It's a very, very complex problem to actually test stuff on airplanes, just because you have the simulation and then you have the actual airplane. So you need to make sure that you have the right pilots, the right configuration, the right plane. And this is a very well-known problem in industry. It's called the optimization, basically, a schedule optimization. So you have an algorithm, you put the different constraints. We need this plane, we need this pilot, we need this. You put the different constraints, and it creates a schedule for you. But it cannot live in isolation. So you have to contribute to it, but also you have to make sure that the business people that are making the decision are being able to use it. And you need a broad, large, different skills there. So you're working in a very big team of at least 30 people and in an agile environment. Otherwise, it's very difficult to combine everything. I was tagged as a product owner. I was working with UX designers, software developers, pilots, other business coordinators to basically transform the business needs into software development by coordinating the project. So I learned so many things on business collaboration. But again, I was learning a lot on business processes, on project coordination, as I said, but I was less and less a data scientist and more a digital transformation consultant. I will so much to get challenged on the technical side. I really wanted to do cool AI stuff. To resonate a bit with the chart on the right, I'm sure you saw it. It was very popular on LinkedIn for a while, but I really like it. I didn't really like what I was doing, and it was causing me my mental health. And so when you see it makes up a big portion of the pie chart. And so I decided to move on to do cool AI stuff. And that's where I went back to school. I mean, kind of. I was more of a freelance, but at the same time continuing to learn. And I pursued a postgraduate at the Artificial Intelligence Group of the University of Brussels. And there I had the opportunity to do an internship in a company that is called Eurosense, that is basically taking pictures, high resolution picture of the ground. And here the question type was, how can we automatically create shapefiles of building footprints to solve land use problems? And you automatically recognize it. It's a computer vision problem. It's awesome. You explore all the different types of models that you try to understand how to fine-tune it, how the different parameters, how the data cleaning part comes into play. And I had my deep learning use case, and I was very happy with it. And now I wanted to use this knowledge and have a direct impact on people. And that's where I joined the consumer goods part on Procter Gamble. So Procter Gamble is a consumer goods company serving billions of consumers around the world with brands like Gillette, Braun, Oral-B, Pampers, Ariel, so plenty of different brands that I'm sure you have at home. And what's the best time to join a consumer goods company than during a pandemic? So there are different types of questions again. How to reach the right person at the right time, at the right cost, with the right frequency. How to prioritize Oral-B sales representatives visit to dentists. It's such different problems types, but they are very complex. And here the passion was around you could build your own stuff on a Jupyter notebook trying to figure out a solution to a problem, but then you go to the entire process of building a data science platform end-to-end so that it can be leveraged by the markets to have an impact. And so that's what I'm doing. And yes, and basically you build something that you can manage centrally, and that every time a change is required, you just have to change a bit the code, push it on GitHub, triggers the immediate deployment of a container that is automatically picked up of the platform. And to me, that was magic, basically. How can CERN alumni, why the CERN alumni are so important for the industry and are so valuable in the eyes of the industry? For data science in Procter & Gamble, I'm working with 10 high-energy physicists from here. And they're so valuable because we have the technical mastery in the eyes of the industry. We understand how distributed analytics work. We have a measurement-oriented approach, rigorous thinking, fresh perspective. But what I really valued on the P&G side is that they hire you for a job based on your interest and not the other way round, which is it brings up the passion. So different machine learning use cases in P&G, from research and development to logistics and shipment to marketing, plants, retailer engagement, and IT. In Geneva, it's the European headquarters. It's mainly focused on retail and marketing. So the data science mission at P&G, and it was much more also driven, and it had more impact during the pandemic. The data-driven decisions had much more impact during the pandemic, and data science mission was also to measure the impact of it through predictive and descriptive models, optimization, A/B testing. I mean, seriously, I could dedicate an entire hour just to talk about all the use cases we have in Procter Gamble and how we use data to solve them, but I would take ages. So if you want to know more, just reach out to us. Either my email address or Michele Flores, which is my direct colleague and worked for 16 years in Alice, and is now, so he will be able to provide a more senior point of view on his work. So the main challenges I faced going from high energy physics to industry was the data science maturity in companies. So when you're a data scientist, you're out of CERN and you're so motivated to do really, really, really cool AI stuff. You think you're going to join a company that is at stage 5 of its data science transformation, but it's not always the case. Many of them are just at the beginning of it and want people to help out, so you cannot always use your skills on direct data. You have to collect them, you have to store them, or they're in the middle of it, they want guidance, they don't really know. So this is what I found the main challenge, not to know. Arriving in a company and having no idea if they had proper database in place. And the second is that data science is a new job in the eyes of the industry. It's very difficult to find coaches and mentors and people that can actually help you to develop your skills. And when you do, it's very, very valuable. So, to wrap up a bit, what I really wanted to emphasize is the dotted line along my talk, is that CERN skills helped me on every aspect of the journey, from my experience at ACA Technologies to Eurosense up until P&G. And my last word, and what I really want to bring as a message, is that and to resonate a bit with the previous presentation, is that to me, cleaning up oceans and helping in the cure to cancer is really the accomplishment of data science. Like it's something we aim for, and that it would be the dream to accomplish as a community, and that's why amazing people like my previous speaker are creating this community. That's what we should aim for. But it's not the only route as well. So you can have a positive impact on your own journey as well. Use your skills for good. Use your network to empower minorities. And my last sentence would be, as CERN alumni, we all have the opportunity to bring positive impact on society. So just if you decide to join the industry, and you can do both, actually. You can join a super great community of people that are contributing to much more advanced problems, and having a job on your side. I think I'm definitely going to join the AI crowd team. But just make sure that if you go to the industry, join like-minded company that put people before cash, because they're touching billions of people. And even if you improve 10% of how it's currently run, it has a huge impact. So just make sure that these companies are aligned with your values. And I would say thank you. So thank you for listening to me. Thank you for the amazing CERN alumni team to bring amazing speakers that are so inspirational. And thank you for inviting me as well. It's really been a pleasure. So open for any questions now.
Many, many thanks for that incredible and inspiring talk, Charlotte. So maybe I can start with an easy question. So I'm sure that the audience is filled with people who are interested in maybe switching their career to data science. And you already gave some advice, but could you give some practical advice to those people who are maybe thinking to switch the career towards data science?
Learn Python. That would be the easiest one, let's say. It's the skills that is the most valuable. But just be curious, talk to people. And my last point was because I had a lot of trouble with it. I was like, I'm not gonna join the industry. I want to have I want to go on startup. I want to clean. That was my own experience. I really wanted to go in that direction, and then I understood how we could actually bring positive impact on society. When I said use your skills for good, it can be as simple as making sure that you're protecting the data privacy of consumer. Or that you just refuse to work on specific problems just because they're not aligned with your values. When I say use your network to empower minorities, it can be as simple as creating an event to promote jobs for IT jobs for women that are not always the biggest representation of the people working there, or just making sure that everything you do every day is to make sure that we all get equal chances as job opportunities. So, when you join the industry, you have a direct impact, like straight. So just make sure that every little things are contributing to the world in a positive way, and the practical and the easiest skill to actually enter the industry is to learn Python and to be curious. They will never expect you to know everything from Google Cloud to. So as long as you're curious, you can learn everything, and just show your passion.
Thank you. There was a really interesting question from the audience. Namely, is it easy or trivial to put people before cash?
Actually, no. It's really not easy. And many companies advertise this and they're not doing it. So it's, as a data scientist, yes, it's very easy because you can have a direct decision and say yes or no. But from the business execution part, it's very difficult. They're in a shark environment, and that's what they want to drive. So but still, you have many companies, and P&G is one of them, that really mean it when they say put people before cash, and they showed thousands of examples during the pandemic, preserving the well-beings of their employers. Before just focusing on the cash. So the pandemic was a really good moment to assess how meaningful the companies protected their people and moved forward. And I feel you could really see it in the way they were managing. And yeah, there are many times that you hear stuff that it doesn't. Even if it brings, we all know that putting cash before people only brings short-term benefits. So when you have very big industries, they usually, they see long-term, and it doesn't doesn't matter. I mean, it's completely balanced afterwards.
Thank you. There was also other really interesting question. What was the most valuable skill you developed at CERN for your current position?
The most valuable one was, okay, there was C++, coding skills. This is very easy to say because I used it everywhere, but it's mainly the end-to-end part. I mean, at CERN, it was like, okay, I'm going to give you a problem. These are the data, here's how you can access it, and I took actually a week to connect to the Atlas to the Atlas system, and I never used a terminal before. I mean, to me that was and this is very valued because that's everything you do is with it, but it's mainly the end-to-end analysis part. So from data ingestion, so looking at the data, making sure that they're of quality, that you can actually use them to develop, and then explorative analysis. Okay, okay, I see data. What is it? I don't understand any of it. It's super abstract. I mean, to me, it was just the leaves, and I just didn't understand any of it. But still, how it's just exploring it and then modeling it. And I feel that 80% of that you spend your time on is actually trying to understand how to come up with something, and that's linked to the curiosity part as well. Up until the sharing of the results. If you develop something awesome but nobody knows about it, it's a bit useless and it's very difficult. I thought I had good communication skills until I joined the industry, actually, because I realized the gap between what I was saying and what was perceived. So learned a lot as well on this side, but still the basis was here. So yeah, I would say the end-to-end analysis part and the coding skills were the most important one, and the passion. The passion about what you're doing is, I mean, I've been passionate about CERN for ages. Up until I was, my grandfather used to tell me about this elite tunnel sitting in Switzerland that would create Big Bang. That was it. I was in love. So no, the passion is also the most important part.
Definitely. Now, speaking about passion, maybe you can, now we have some minutes left, so maybe you can tell about some of the most interesting use cases that you have done at P&G.
Yes. That's yes. That's a good one. I can provide many different examples. So the most passionate one would be, so how to reach consumer at the right moment, at the right frequency, at the right time is a very complex problem. I mean, this advertisement part has become a kind of toxic environment. You might you might judge from. I mean, that's what I judged before entering P&G, and here the idea is, okay, it's no one wants to bombard you with thousands of images to make sure you buy something. I mean, it's a very old model. It's a deprecated model. So how to combine all of these data that, I mean, as you use Facebook, Instagram, as you interact with Google or Amazon, how to make sure that they're coherent and that it's not attaining your privacy. So this is a super interesting use case that I had. I'm trying to think about other. So I joined a team working on many different projects, and it's also about P&G has a lot of impact in terms of the environment as well. And so they have target of being carbon neutral by 2040. So to do that, you have to get a lot of creativity. So reducing water in plants and making sure that, okay, you can do that for one plant, but how do you do it for across the world? And these are, I mean, it's super, super interesting. And how you can, you're basically a startup within a big company, you know? So you have access and they listen to you and you can really have an impact. And it's what I find really, the most passionate about. I'm the most passionate about is the fact that you have a direct impact, a real one. I mean, if you optimize, if you save 10% of water in a plant, and you scale it across the millions that there is around the world, then you have a real impact. And it's a direct one, and it's a short one. It's not, oh, in 10 years, it's really like you can act on it straight, and you can see the benefits of it. So that's what I'm the most passionate about.
Thank you. That indeed sounds really interesting and exciting. Maybe because now we have been talking about this passion, maybe can you describe briefly how your actual day-to-day work is? Like, do you just code or do you attend to meetings? And is it really stressful? Because as a particle physicist, we always have deadlines for next conferences and so on. So how is it at PNG?
It's not that different as it was at CERN, actually. It's you code, you stuck on a problem, you come to your team to find solutions. So you make presentations, you show up charts, and you say, okay, there is a problem here. How can you help me? Then you attend business also meetings. You try to align of. You might have developed an awesome algorithm that cannot fit the organization because it was not made to use it in the first place. So how do you understand the pain points of people, like the people that are working in the markets? Like, how do you make sure you understand the problems correctly? How do you make sure that you have basically, to answer your question, just meetings with them where you ask questions, where they give you feedbacks, and then the thrilling part is when you activate an algorithm and you have people in the markets screaming at you. No, I'm joking. It's just this part when you activate stuff is super thrilling. So everyone is tense, but it's again, it's still meetings, codings, and before there was you could travel there, so it was much more human. But I would say really the same, maybe more meetings because you need to help the people that are in the market, so you need to listen to them a lot. And but apart from that, yes, Jupyter Notebook, Google Cloud. I mean, it's still what I was doing at CERN.
So it's perfect as well. All right. Thank you very, very much, Charlotte. It was a pleasure to hear about your experiences and have you here at this event.
Thank you. Thank you, Katja. Have a good day.
A huge thank you to all our speakers for such great talks. After a short break, you will be able to join some of them at our networking table from 4:30 in Restaurant 1. Visit our booth in Idea Square or join fantastic live visits of our experimental areas, the 4 LHC experiments, but also LAIR and the antimatter factory from Building 40. For those of you who couldn't watch Kitty Liao's presentation because of the technical issues which we experience, Kitty gives her presentation now at 4 o'clock in the Globe Auditorium. Enjoy!